Okay, hello everybody. So my topic for today will be fixing mobile application security. Just very briefly about myself. So my name is Sven. I'm living in sunny Singapore, so I had already quite long journey, still a bit jet lagged. I'm doing pen testing already for a while. And yes, I'm also shifting a bit left, also being a security architect during the SDLC when developing web apps and also mobile apps. And I'm also one of the project leaders for the mobile security testing guide and for the mobile AppSec verification standard. Okay, so why mobile application security? Why do we need now mobile application security? Is this not already covered when we are doing the web app testing guide and also the ASVS? Do we really need another project for that? So let me clarify a few things. There's a different attack surface when we look at mobile applications. So there's, for example, interacting with the operating systems. So when you think about your iOS and Android app, they are interacting a lot with the operating system. It's, for example, the keychain, different encryption APIs that they are talking to. There's local storage. I mean, all of our phones have dozens, sometimes hundreds of gigabytes of storage. And these kind of things are just there. They will just store a lot of data. And there might even be sensitive information that will be stored on your mobile device. Also very different to web apps is the local authentication. On iOS, since iPhone 5S for already 4 or 5 years, we are used to use Touch ID to log in. I mean, we maybe log in once in our mobile app with your username and password, and then we can maybe already configure to use Touch ID, and then the authentication is then already done partly on our mobile device. Or also iris scan, or also the face scan. Another huge attack vector is reverse engineering, especially when it comes to games. Reverse engineering is quite crucial here, meaning that the attack vector is quite huge. Because, of course, gaming vendors or gaming companies do not want that you're able to cheat or that you mod the game apps. Same applies to apps that have maybe a lot of intellectual property in it, like an OTP app, for example. Okay, so I know that you all have either your phone in your hand or just right next to you, so please grab it. Go to menti.com and type in this passcode. I just want to make a quick survey with you guys. Oops. Okay. So just go to menti.com, type in this passcode here on the top right corner, 917949. And the first question I want to ask you is cross-site request forgery, a vulnerability that is applicable to mobile apps? Yes, no, CSRF? Okay. So just wait for a few more seconds. Okay, seems majority. Okay, that's definitely going into one direction. Okay, let me ask you another question. Okay, at least one needs to ask CSRF. Okay, so let me ask you another question. Cross-site scripting, is this also a vulnerability that is applicable to mobile apps? Yes, but only reflected. Yes, but only stored. Yes, reflected and stored, or no? Okay. Okay. Only stored. Nobody reflected? Okay. Okay. So let's continue. Okay, so what about cross-site request forgery? If you think about the attack vector for cross-site request forgery, it's that we need to be logged into a web application. Somebody is sending us a malicious link, we click on it, then we see maybe some funny cat pictures, and in the background, a request is sent to the application where we are logged in. So if you think about this, this is not really applicable usually for mobile apps. If we click on something, when we get a mail or a message, then this usually will open in our browser. There might be something like deep links or maybe some edge cases in mobile apps, but usually the attack vector for cross-site request forgery is not really there. So this is something that we need to think about when we want to flag this vulnerability for mobile apps. The same is with cross-site scripting. Stored cross-site scripting, or no, different. Cross-site scripting is only a vulnerability if you have a browser or a browser engine that would render the JavaScript. If you have a native application, no JavaScript will be rendered. So this attack vector for native application is also not applicable. If you have a web view in your mobile app, then yes, stored XSS might be an issue if it's already in your endpoint. But again, to trigger reflected XSS in a mobile app, pretty hard. What I want to say with this is don't blindly trust your scanning tools output, because usually the scanning tools are there for your web applications, and you need to think a little bit different for mobile applications, if this really makes sense or not. So you can also have a look at our mobile security testing guide for this. There are also different kind of vulnerabilities. So so again, these are just examples, there are way more. So there's the disclosure of sensitive data on your mobile device. So this can be storing data in clear text, data that might be locked on your mobile device, maybe you expose encryption keys in your memory. The same applies to the build settings and the code quality of your mobile app. Maybe the mobile app is running in debug mode or not in production mode, all these kind of things. Another thing that we have seen, this is a tweet from Natalie from Google Project Zero that she tweeted end of last year. We can see that some of the vulnerabilities that we only know from the server side are actually shifting also to the client side, to our mobile app. So here you can see that directory traversal was found, one in Outlook, in the Outlook Android app, and in the Telegram mobile app, which is also kind of bad. So all of these things that I just summarized were leading to creating the OWASP Mobile Security Testing Guide project, which we were starting almost 2.5 years back, and this is the outcome. So let's have a look at the different documents. So first, I want to talk about the MASVS, the Mobile AppSec Verification Standard. So the MASVS started originally as a fork of the ASVS. So everything was already in GitHub and in Markdown available, so we just forked this project, got rid of everything that is web-related, and just purely got in all the best practices that are applicable to mobile apps. So everything that we summarized here is mobile-specific, on a high level and OS agnostic, meaning it's applicable to iOS and or Android, and is also applicable in the future if any other operating system will come. So this is an example of, or a subset of the requirements that we're having for the MASVS, specifically now for data storage. And if you look at the first one, okay, this is not really working. The first one is system credential storage facilities are used appropriately to store sensitive data such as user credentials or cryptographic keys. What does it mean? Use the keychain on iOS, use the key store on Android. Because there's simply no excuse to not encrypt sensitive data on your mobile phone, because you already have all the encryption APIs anyway available. So it's very easy for you. In order to come to these requirements, there were obviously a lot of opinions. So some people definitely wanted to have the requirements in the MASVS, some of course not, so this was a process. And to give you an idea of this, we have requirement 2.5 here. The clipboard is deactivated on text fields that may contain sensitive data. So let me give you a little bit of background to this requirement. When you start an app, for example, on Android and you background it, it will still be able to query the clipboard or to read the clipboard, meaning if you copy your username, your password, your credit card or whatever, a malicious app in the background might always be able to read the clipboard and this information. So that's why we came up with this requirement. So please get again your phone. And let me just ask you a question. Is it a useful requirement to prevent pasting on input fields in mobile apps? Is it useful or not? If you think now about this attack vector. Okay. No, yes. Okay. Okay, seems the trend goes to no. Okay, let's go back. Okay, so if you think about it, about this attack vector, if someone is copying something and you prevent them from pasting into the input field, then the malicious app will anyway already have the data that you put into the clipboard. So the malicious app will definitely get its data, but on top of that, you're saying to the user, you cannot paste into the input field, which is of course very bad, meaning that also no password managers will be working anymore. And so it will be a total contradiction to the actual intention of this requirement. So that's why we got rid of this. So this is just one of the examples how we were trying to get requirements in and also out of the MASVS. So our approach for this was, or our philosophy, was so-called Occam's razor. So this is a principle from philosophy and supposed to exist two different explanations for an occurrence. Usually the simpler one is the better. It's just another way of saying keeping things simple. So in the end, we came up now with 44 different security requirements, so-called level 1, 18 defense in-depth measures, level 2, 12 anti-reversing controls, and everything is covered in 8 different domains. So what is now level 1, level 2, and resiliency against reverse engineering and tampering? Level 1, as I was saying earlier, the requirement with the keychain and the key store, this is something we consider as a level 1. Every mobile application should encrypt its data on the OS. There's simply no excuse to not do it because it's also just so easy. Level 2 is something like SSL pinning. These are requirements that make sense for some mobile applications. For example, if you have financial transactions, then these kind of things you should consider. And then on top of that, we have resiliency against reverse engineering and tampering. These are security controls like jailbreak detection, root detection, anti-debugging, these kind of things that might be useful for games that really want to make the reverse engineering as hard as possible. As hard as possible because you will never be able to completely stop it, but you can just make it as hard as possible. Okay, so now I was talking a lot about security requirements, but why are they actually so important? Because we want to avoid this. Because this is what happens for years, and at the moment it's still for the majority of pen testing engagements. The pen tester comes, he delivers a report with critical vulnerabilities. The app was supposed to go live tomorrow. Everybody panics. Developers need to work late to implement the fixes. The release gets delayed, and everybody hates you. So the root cause of this problem is that usually nobody with security in mind was part of the project, and from a security point of view, the project was anyway going to fail. So the MASVS cannot be the solution, but it can be part of the solution because it can be very useful then at the beginning during the early stages of development to give the developers really a baseline for the requirements that they should think about. And this also helps within enterprises to actually build internal baselines for mobile security because usually at the moment there are not any, at least according to my experience. So to determine the security requirements, let me give you another example. Security controls are never enforced only on the client side, but only on the respective remote endpoints. I mean, it's a no-brainer, right? But at the end of the day, developers are, of course, always under a lot of pressure, and if you do not give these kind of requirements to them, they will simply forget it or under too much pressure to implement it. So in order for consistency, these kind of things should just be part, or these kind of security requirements should just be shared with them in their Jira, in their pivotal tracker, whatever they are using, and then you just need to redefine those security requirements whenever there are any changes. The really cool thing, which was also quite surprising for us, is that we are getting mainstream. We're already referenced by the NIST now, which is really cool. And yes, so where can I get it? The MASVS is in GitHub. Everything is in Markdown. We also chained it with Gitbook, so you can easily read it. We also have an EPUB, and you can also export it as a doc. So please download it, read it, use it, and please give feedback. If there's anything missing, anything wrong, please just create an issue, and we're happy to discuss. We also have our own Slack channel in the OWASP Slack, so please just approach us. And we also have now translations into Spanish and Russian, which is also kind of cool. Okay. The other document that we have been creating, or we are maintaining, is the OWASP Mobile Security Testing Guide. So the MSTG is now a manual for testing the security maturity of mobile apps. So the cool thing is that everything is now mapping back to the MASVS requirements. So all the requirements that we are having, we have created test cases for iOS and Android, and all of those test cases really describe now in technical detail how you can verify that. And we are focusing only on iOS and Android native applications, so things like mobile application development frameworks like Apache Cordova or Kony or Xamarin are not really part of the project yet or the book. But the good thing is through the MASVS, we can really ensure completeness and a consistent testing methodology. So if anything is missing or any new shiny feature from iOS or Android is implemented, we just add a requirement and then we just create the test cases for it and can ensure therefore consistency. So the structure of the MSTG is we have an Android testing guide and an iOS testing guide, which describes all the security mechanisms, what you can do for reverse engineering, and of course all the different test cases. But while we were writing it, we realized that there are a lot of not overlapping, but we were duplicating things, because for Android and iOS, when it's about cryptography or authentication, things like stateless authentication, this is not really Android or iOS focused. This is something generic. Therefore, we were creating a general testing guide that is covering these topics. Okay, so let me give you, oh, I forgot one thing. Let me quickly show you. Okay, so this is how a test case usually looks like. So this is on Gitbook, and every test case has an overview. The overview just briefly describes a little bit of background and what the intention of this test case is. Then we have one section about static analysis. That is just trying to give you the correct keywords in order to verify this test case. The static analysis part usually also has the best practice available. And then we have, and then we have the dynamic analysis part, where you can verify this test case, where we write down how you can verify the test case when you're executing the web app. Okay, so let me give you another practical example of how the MSTG can help you and how the MSTG is describing things. So I guess everybody of you has heard about SSL pinning. So just that we are all on the same page, with SSL pinning, it's just on top of TLS. So when you implement SSL pinning, you either pin against the specific CA, or you pin against the intermediate certificate or the actual root certificate that is available on the web server. Or you just pin against the public key of the certificate. So how can a penetration tester usually test, especially now on iOS apps, how can he deactivate SSL pinning? So usually we were using jailbroken devices and SSL kill switch, so then it was quite easy to get rid of SSL pinning. The problem just nowadays is that jailbreaks are becoming a bit more complicated. It's also sometimes hard to maintain jailbroken devices. Therefore, it's good to have an alternative approach. So the alternative that we have at the moment is using a library called Frida, and with Frida we can use so-called dynamic instrumentation. And the awesome thing is that we can actually do it then on a non-jailbroken device. And the approach for this is that we are repackaging the IPA with this library, and then we're just installing the app, we execute it in debug, or we start it in debug mode, and then it's possible for us to, for example, disable things like SSL pinning. So let me show you a quick demo on this. So on the left side, you can see my terminal, and I'm starting now the Snapchat app in debug mode. And on the right side, you can see the screen of my iOS device that is non-jailbroken. I think this takes a while. Where's my mouse? Okay. So what you can see is that the app is now starting soon, and when it's starting, also the Frida server that is part of the iOS app will be starting. And this is all done with iOS deploy. Now we're in the so-called early instrumentation mode on the right side in our app. And on the left side, I'm calling now or starting a tool called objection. And this tool is now communicating to the Frida server in my iOS app. So the whole communication is now going via USB. So my iOS phone is connected via USB to my MacBook. With iOS deploy, I was starting the app in debug mode. And with objection, I can now connect to this Frida server. So you can see on the left side, in blue, that's the bundle ID of Snapchat.